Multi-wavelength astronomy is basically looking at our universe with the full spectrum of light at our disposal. So the light that we see with our eyes is the visible part of the electromagnetic spectrum. But that spectrum extends dramatically, much lower energy, longer wavelengths out into the radio, microwave and radio, and then higher energy, the ultraviolet, the X-ray, the gamma rays. This is an entire sweep of the electromagnetic spectrum. And our eyes are only sensitive to the visible. And our atmosphere here on Earth actually protects us from many, many wavelengths of light. Ultraviolet light and high energy light is very damaging to life. It also blocks much of the infrared part of the spectrum. Hubble is above the Earth's atmosphere. We're in a low Earth orbit, and so we are above much of the atmosphere, and so we are free to observe in the ultraviolet and the near infrared. So we have ultraviolet instruments and filters on there that expand our vision greatly in the ultraviolet and very uniquely from space. And we also have instruments that go into the near infrared now. So that stretches our vision in the other direction, into the infrared. And getting into space has been so powerful for us. When we get up above the atmosphere and we're able to look at those same objects now that we saw invisible before, but add that ultraviolet part of the picture, the infrared part of the picture, we're now taking our vision of a very narrow part of the object and we're widening it to get the big picture. So for example, when we look in our own solar system, when we look at the ultraviolet at a planet like Jupiter, the ultraviolet actually revealed that there was motion happening in the polar region of Jupiter, very similar to the aurora on the Earth. That gave us a piece of the picture of our solar system, of Jupiter, and of the sun's interaction with the planets in our own solar system that we could not have seen without that ultraviolet view of the solar system. Mystic Mountain is a beautiful multicolor image of a star-forming region, or a stellar nursery. What we see in the visible from Mystic Mountain is how the light from these newly born stars is engaging with the material around it, the gas and the dust that's still there that has yet to form stars. We look at Mystic Mountain not in the visible now, but in the infrared. We're actually able to peer through a lot of that gas and dust. Multi-wavelength view, looking at Mystic Mountain in both the visible and the infrared, lets us see that picture of star birth, early star formation, in a much more nuanced and detailed way than either just the infrared or the visible alone would allow us to do. So multi-wavelength astronomy has allowed us to take objects that we've been observing for hundreds of years and put that new color on them to understand them better as objects, how they evolve, the dynamics that's going on there, galaxies, stars, nebulae, supernova remnants. And now James Webb Space Telescope, it's going to add a tremendous amount of infrared information to that multi-wavelength picture. It's going to lead the way in that area of the electromagnetic spectrum, and it's going to continue this multi-wavelength investigation of our universe for decades to come.